Selena, you need to move. This is your seat in here is the third one back, unless you want to sit over there. Okay. So in the first lesson, it was all about graphs of rational functions, right? In this lesson, it is about we're simplifying expressions. Right? Remember, an expression is not an equation. There's no equal sign. And the ways that we simplify it, which we don't do all today, we start by simplifying, and then we multiply, and then we divide. Right? In the next lesson, we add and subtract. Right? We're not doing those today. We do that one next class. But again, rational expressions are fractions. So when we're talking about simplifying rational expressions, it's going to work out pretty much the way it works when you simplify a fraction. Right? And the same thing for the multiplying and dividing. So in each case, I'm going to show how we would do it with a fraction, and then we'll do it with a rational expression, and then you'll give it a shot. Okay. So how to simplify a fraction? Generally, some of this stuff, you may not precisely follow these steps, and you might get it right just because you're doing some of it in your head, but it's important to understand these steps when you're doing it with rational expressions, because you're definitely going to have to do this part. 6/8 is not a simplified fraction. If you remember, the only way you can simplify a fraction is to cancel common factors from the numerator and denominator. In this case, 6 has factors of 2 times 3, and 8 has factors of 2 times 4. Now remember what we mean by a factor. Factors multiply, right? So since we have, broken this out so that we can see a common factor of 2 in numerator and denominator, then we can cancel those, cancel, and get a simplified fraction of 3/4. That's how you do it. Now, what we tend to do, which is not correct, is to do something like this. Let's say if I say 6/8, and I could say this is 4 plus 2 over 6 plus 2. That we tend to look at it when we see even a common term in the numerator and denominator and think that you can cancel that, but you can't, right? That does not work. And if it did, 6/8 is 0.75. 4/6 is 2/3. Right? It's not correct to just cancel one term in the numerator with one term in the denominator. It has to be a factor of the entire numerator and a factor of the entire denominator. Right? So make sure you do that. Don't try to do something like this. So now we're going to simplify rational expressions. It's similar steps to what we just did for the fractions. But there is one more thing that we have to worry about. Again, rational expressions, you got to make sure the denominator doesn't equal 0. So there's an added step that we didn't have. And the added step is make sure you restrict any values of x that would make the denominator equal 0. The zeros of the denominator, right? Zeros of denominator. Singular. So if I'm following the first step, factor the numerator, factor the denominator. This is why this chapter gets hard, because we generally didn't do great when we came to factoring in the first place. And now you're going to have to do it, multiple times as part of doing a bigger problem. X squared plus 7x plus 10 is a simple kind of factoring, but you still need to remember how to do it. Right? How does that factor? Somebody? The factors of 10 that add up to 7. 5 and 2. Okay, so how does it factor? X plus 5, x plus 2, right? I'm not going to stop on every one of these problems and discuss how we factor things. If you don't get it, I'm sorry. But we can't turn every one of these into an exercise in how do you factor it, the most simple kind of factoring, okay? Especially when I've already told you what the two numbers are. What about this one? How does this factor? Factors of -10 that add up to -3. -5 and 2. Okay, what does that look like? Factor. X minus 5, x plus 2. Okay, so that's the first step right there. Check. Okay, at this point, you've got to state the restrictions. What are the zeros of the denominator there? What values of x are going to make that denominator equal 0? 5 and -2. So the restrictions are x does not equal 5 or -2. Right? You just have to make sure x doesn't have that value. Honestly, what is that? That's a domain. Okay, now simplify. That was the restrictions, right? Cancel the common factors, right? So what's the common factor in the numerator and denominator? X plus 2. So cancel, cancel, and the answer is x plus 5 over x minus 5. So the entire answer is this, right? It's this, and it's this. If you were just looking at the x plus 5 over x minus 5, you would think that it only has a restriction of x equals 5. But the fact that it started with x plus 2, you still got to include the -2. That's why we do the state restrictions before you start canceling things, right? They become part of it. So factor, state restrictions, cancel common factors. Easy? Okay, try this one. This will be the you tried you're going to hand in. So write it down on a piece of paper you can hand in. Should work pretty similar to the one we just did. That's right. Good job. Person done. The factors of negative 8 that add up to 2. Negative 4 plus negative 4 is 2. Negative 4 times 4 is negative 8. Get it? If the 8 is negative and the 2 is positive, then it's plus 4 minus 2. Negative 4 plus 2 is negative 2. You might want to look at the signs there. Doesn't add up. Do you get it? Plus 4 minus 2. Good job. What about the restriction? And but before you start canceling, just look at what are the zeros of that denominator. 3 and 2. X is not equal. Positive 3, positive 2. I know you got it right. Did you use restrictions? Yeah. Okay. Good job. Press next. Negative 4 times 4 is not negative 8. Factors of negative 8, meaning by two numbers you multiply to get negative 8, you add to get positive 2. And even this one, negative 3 times positive 2 is negative 6. That's positive. So remember the thinking. To factor, these are simple quadratics because the a equals 1, right, the coefficient of x squared. So it's a one-step process. What are the factors of negative 8 that add up to positive 2? And you would say plus 4 minus 2. Right? What are the factors of positive 6 that add up to negative 5? Right, well, let's see. If the last number is positive, then either both numbers are positive or both numbers are negative. Since they add up to a negative number, they're negative. So it's negative 2, negative 3. I'll go x minus 3 times x minus 2. Right, that's the check. Did that one. State restrictions to the domain at this point. Before you start canceling, what would you say are the zeros of the denominator? 3 and 2. So you say, as a restriction, you're going to say, x does not equal 3, comma 2. Okay, now, cancel the common factors. What's the common factor? Minus 2, minus 2. So the answer is x plus 4 over x minus 3. Can I cancel the x's? Can I also go? No. Remember, that would be canceling terms in the numerator and denominator. You can only cancel when it's a factor of the entire numerator, something that's multiplying times the rest, and a factor of the entire denominator. So no, that's as simple as it gets. The answer is all of this right here. In the homework, there's going to be 3 problems like this, right? There'll be 3 that are just simplify. There'll be 3 that are multiply, which means simplify when you're done, and there'll be 3 that are divide. That's how it works. A couple of things to look out for are like this. Although I do try to, your problems are selected to not be the overly complicated ones. But if I was going to do this one here, the first step would be factor the numerator and denominator. How would I factor the numerator? What's the common factor between 12 and 4x? 4. Doesn't 4 go into 12? So if you factor out a 4, you have 3 minus x. Okay, and then x squared minus 9. That's a particular kind of factoring. Do you remember what we call it? Difference of squares. How does it factor? I mean, you're going to see these all the time in these problems. They use them because they know that you're having to factor inside of this problem, and it's considered to be just an easy kind of factoring. We can't turn these into the theory of relativity here, okay? X plus 3 times x minus 3. I mean, you got to know that 9 equals 3 squared, right? And then that's the pattern. Right, so now at this point, I could say that I've factored it completely. I'm going to actually do one more thing. It's the reason why I'm showing you this one right here. But let's state the restrictions before we do anything. What are the zeros of the denominator? 3 and negative 3, right? Negative 3, 3. So you're going to say restrictions are x does not equal 3 or negative 3. Now, cancel common factors. Do we have common factors in the numerator and denominator? Meaning, is 3 minus x the same thing as x minus 3? No. So you don't have commutative property for subtraction. I mean, just take example of this. Is 3 minus 1 equal to 1 minus 3? Right? Is that the question mark? That's 2. That's negative 2. In fact, they're not equal. So no, we don't have common factors now. But here's the thing. They're opposites. So you could take a step if it helps you to do it this way. You could say, let me factor out a negative 1 out of both of those. Let me make this negative 4 times x minus 3 in the numerator. Right? The negative times x is negative x, and negative times negative 3 makes positive 3. So I switched the order, and then I put a minus in front, because I know by switching the order, I made the whole thing opposite of what it was at the beginning. So now I have x plus 4 and x minus 3. And now I do have the same factor in the numerator and denominator. Okay. So when you see that kind of thing, like a 3 minus x instead of an x minus 3, you switch the order and put a minus sign in front. That'll take into account the fact that you just switched the order of subtraction. Right, so cancel, cancel. This is negative 4 over x plus 4. Again, can I cancel the 4s? Are the 4s factors of the numerator, factors of the denominator? No. You could consider 4 to be a factor of the numerator. 4 times negative 1, okay, that's a factor. But that's just one term. Remember, terms separated by pluses or minuses. So you can't like go through and cancel. You're done right there. The answer is all of this right here. Okay, another kind of problem, and I know you've got at least one. You might have them actually as part of the multiply and divides too. But this always causes us a little trouble. And that is something that looks like this. And how does that look different than the ones we've done up till now? What do you not see? You don't see any pluses and minuses, right? So in fact, there's nothing to factor. This first step, when you're trying to do this step, right, factoring means you have more than one term and they have common factors, or there's a pattern that we know that we can back out some factors. When there's only one term in the numerator and only one term in the denominator, there's nothing to do. I mean, this is the kind of problem we did at the very beginning of the last chapter when we had to practice on the properties of exponents before we ever got to this stuff. So if you have something like this, then you don't have to worry about this first step right here, right? NA, not applicable, because there's only that was a bad draw. Right, only one term in numerator and denominator. So no factoring. Okay, so we can move to the next step. State the restrictions. What are the zeros of that denominator? what value can x not have? Because it would make the denominator equal 0. 6 squared is 0. What number squared equals 0? 0, right? The restrictions are x does not equal 0 and y does not equal 0, right? Since there's no x plus or x minus, it's actually, you could think of it, it's like x, that could be like x minus 0 squared, y minus 0 squared. Okay, then you would probably say, okay, 0 is the 0. But if you don't see that plus or minus, that just means x equals 0, y equals 0. Okay, then you start to simplify. Cancel the common factors. Okay, let's see. 6 goes into 24, right? That'll be 4 times. So let me write that down. That'll be I'm going to put -4 as a starting. What do we do to simplify? You got x to the third over x squared. This is the properties of exponents thing. What do you do with the exponent? Subtract, right? And so how many x's do I have in the numerator? 1, right? That's x to the first. And what about the y's? Y squared over y to the third. If you subtract, you will get 2 minus 3, -1. And then we don't leave a negative exponent. How do we get rid of the negative exponent? You flip it to the other side, right? This is -4x over y. I mean, I personally would not have made it look exactly like that. I would have said, okay, there's 2 x's here. They cancel 2 of the x's there, and there's 1 left over. There's 2 y's here, and that cancels 2 of the y's, and there's 1 left over. Not subtract, make it a negative number, have to flip it. I mean, if you can see there's more y's in the denominator, you know, I mean, it's okay any way you do it. That ends up being the answer right there. So those last 2, I just say those are where you will get tripped up, right? When you've got something which is, you know, 3 minus x, and you want to cancel it with an x minus 3, you're going to have to switch them and put a minus in front. And then when you see something like this, there's no pluses or minuses, which means there's only one term, then you can't factor. Factoring is when you've got more than one term. Okay, multiplying fractions. So multiplying fractions. I'm going to show it in 2 different ways. You remember the process to multiply fractions? And here's 6 over 5 times 7 over 8. What do I do to multiply those? You do not cross multiply. You just go straight across, right? And you're multiplying fractions. That's like 6 times 7 over 5 times 8. Right? That's 42 over 40. And then, is that the most simple version of that fraction? Or is there a common factor you could? There is a common factor, right? So you could say this is 2 times 21 over 2 times 20. And then you cancel the common factors, and you get 21 over 20. Or you could factor first, make this 6 into 2 times 3 over 5 times 7 over 2 times 4. And then you can cancel the common factors when you're multiplying, even if they're not in the same fraction. Right? They don't have to be, right? The 2 over the 2, they're all in the same fraction. Because in the end, when you multiply, you're going to run them all together anyways. You know, you could, before you multiply and get those bigger numbers, just cancel the 2's. And now multiply. So cancel the common factors, multiply the numerators, multiply the denominators. 21 over 20. You know, our job here is not to multiply fractions. It's going to be to multiply rational expressions. And we will want to factor and cancel before we take the next step. It'll be more like this than it is like this. Okay. So how to multiply rational expressions? Again, the steps are similar to the fractions, but we got that one step which is not applicable when you just got fractions of numbers, right? Because those numbers don't include a zero in the denominator, but they might include a zero in the denominator if we have a problem like this. So the first step is going to be factor all the numerators and all the denominators. So x squared plus x minus 6. Factors of negative 6 that add up to positive 1. X plus 3, x minus 2. X minus 5 can't be factored, right? That's simple. Okay, x squared minus 25. Difference of squares, how does it factor? X minus 5, x plus 5. Okay, x squared plus 4x plus 3. Factors of 3 that add up to 4. 3 and 1, right? X plus 3, x plus 1. Okay, so that's the first step. Check. Okay, state the restrictions now, right? And this time, the restrictions are the zeros of the denominators, right? Plural, because we got more than one denominator. You got to take into account both. Zeros of denominators, plural. Okay, well, we should be able to see that was pretty easy. What are the values that I have to restrict? What's the 0 that comes from x minus 5? 5. What's the 0 that comes from x plus 3? Negative 3. What's the 0 that comes from x plus 1? Negative 1. So state those restrictions before you start canceling these factors, and it looks like you don't have them anymore. Okay, now, so we did that. Cancel the common factors. And in this case, like I said, you can cancel these in between fractions. Right? We don't have to run them all together into one fraction before we start to cancel them. Right? So what's common? What are the common factors you see? Numerators and denominators. About x plus 3? X plus 3? Cancel. Any other common factors? X minus 5? X minus 5. Any other common factors? No. We got x minus 2 times x plus 5 divided by x plus 1. So that's the answer. Check. Cancel the common factors, and we just multiplied them. You know, then we did multiply, right? X minus 2 times x plus 5. Now it's all in the same fraction. Okay. So try one on your own. common factor between 2x and 8? 4. 4 divides into 2. What about 2? How do you factor 2x minus 8? What's the greatest common factor between 2x and 8? 2. It's another place where we get tripped up, which is, you're probably getting a little better at these because we've done a few of these so far, and you might, maybe even the difference of squares, but then you see one like that, and you go, oh my, what do I do with that? Remember, greatest common factor. If you can't do anything else, look to see if there isn't one factor then common to both terms. And in this case, there is, right? 2. So just factor out a 2. That's right. So now this goes here, right? This is this. This is this. So you're multiplying all this together. So if you get the factoring part's up there now. Okay. Now you can go on to the next step. State the restrictions. Should -1 be a restriction? Why not? It's in the numerator, right? The restrictions are in the denominator, right? They come from the zeros of the denominator. Right? So this was the right factoring. These are the restrictions. Cancel common factors. Okay, there's an x minus 4. Do we see any other x minus 4s? Right there. There's an x plus 4 and an x plus 4. Anything else in common here? No. I mean, these are on the same level, right? They don't cancel each other, right? The x plus 1 doesn't cancel with anything. So this is 2x plus 1. And x plus 4 times x plus 4 is x plus 4 squared. Now you could leave it like x plus 4 times x plus 4, but that is what we mean by squaring. Okay, so cancel common factors, and then we just run it all together. Multiply straight across the numerators, multiply straight across the denominators. Okay, which leads us to the last thing, which is divide. So first we remind ourselves, how is it that we divide fractions, right? Not rational expressions, but just fractions. Remember how I did this. Right. So the first step dividing by a fraction is like flipping and multiplying. Right? You take the thing you're dividing by, which is the divisor, which is the second fraction. You're going to turn it into a multiplication by flipping the second fraction. Right? It looks like this: 2/3 times 5/4. And I don't remember exactly why I left this spacing like that, but at that point, we've turned the whole thing into a multiplication problem. So now we're just going to do whatever we did with the multiplication. So in that case, you could either, multiply straight across 10 over 12, cancel the common factors, or you could have canceled the 2 into the 4 as a first step. Make that 1 over 3 times 5 over 2, right? By canceling, 2 goes into 4 twice. And then run them together. So remember, dividing by a fraction is like multiplying by the reciprocal. And that's how we do it. That's what we're going to do with the rational expressions too. The very first step, we're going to turn it into a multiplication problem because we already know how to do the multiplication. Okay. So again, what's the one step we have to add when we change from, what's that? Okay. Well, what's the one step that we always had to add? Every time we moved from doing these things with fractions or doing them with rational expressions, we had to worry about restrictions, right? Make sure you don't divide by 0. So that's why we need to have restrictions to the domain. It was a step we didn't have to worry about with fractions. So the very first step, we got to change this into a multiplication problem by doing what? Flip, right? So this step looks like this. X minus 2, x squared plus 2x plus 1 times, right? Turn that into a multiplication. X squared minus 1, x squared plus 3x minus 10. Right, that's the first step. Turn this division problem into a multiplication problem. Check. Now I'm going to, already wrote it on this slide. So now we're going to move on to the second step with this multiplication problem. Factor numerators and denominators. X minus 2 can't be factored. X squared plus 2x plus 1. X plus 1 squared times x squared minus 1, difference of squares, say it, x plus 1 times x minus 1, and x squared plus 3x minus 10, x plus 5 times x minus 2. Right, that's the factor part. Now, when it comes to the stating restrictions part, okay, this is just copied already from what I just did. If you didn't get it yet, that's it. When it comes to the stating the restrictions part, right, obviously we have to worry about in a division, right, if I say A divided by B divided by C over D, right? That's got two denominators in it that I would have to check and make sure those don't equal 0. But actually, if this numerator of the second fraction equals 0, then I'm dividing by 0. You know, this is a divide, this is a divide. That's why B and D cannot be equal 0. But that's also a divide. There's 3 divisions here, and you can't divide. This whole fraction cannot equal 0. And how is it that a fraction equals 0? Because the numerator equals 0. So when we look for restrictions in division, we're not just looking here and here. We have to look in here, here, and here, because any one of those would lead to a divide by 0, right? So the restrictions are zeros of denominators and I'm just going to say the second numerator. Okay, well, what are they? X does not equal. We go to the denominators first. X plus 1, the 0 is negative 1. Right? X plus 5, the 0 is negative 5. X minus 2, the 0 is 2. And now we've got to go up here also, right? Plus 1 would have a 0 of negative 1, but we already have negative 1. And then X minus 1 would have a 0 of 1. Okay, so you got to check all of those. Okay, at that point, you're just doing whatever we did with multiplication. Now it will be no different than the rest. Oh, I guess I was going to finish it on this side. Okay, so cancel common factors. Plus 1 cancels with plus 1. Minus 2 cancels with minus 2. Anything else? No. So here's the answer. X minus 1 over X plus 1 times X plus 5. Good. So try it yourself. See how far you can get. See if you can get that first step at least, right? Change it to a multiplication, flip, and multiply. It's the last slide. If you think this is hard, next class will be harder. Because what's easier or what's more hard? Multiplying fractions or adding fractions? What do you have to have when you add fractions? Common denominator, right? Here we can just keep going. We don't worry about things like that. That's a step which is a lot more complicated with rational expressions than just the pure multiplying part of it. I mean, the process of multiplying is straight across, and not too complicated there. Finding common denominators when your denominators are factorable rational expressions, more difficult. So what's the second fraction going to look like? Flip it. Flip this. Who thought of how to factor this numerator? What was that? X squared plus 5x plus 4. Positive 4, positive 1, right? So what does that look like? X plus 4, x plus 1. Okay. Who thought of how to factor that denominator? Negative 3, positive 4. Let's see, negative 3 times positive 4 is negative 12. Negative 3 plus positive 4 is 1. So that works. Okay, who thought of how to factor 2x squared minus 6x? Again, what kind of factoring are you going to do here? Is it a difference of squares? It's a difference, but those aren't squares. So what kind of factoring is it? Starts with a G, ends with an F. Greatest common factor. What's the greatest common factor? 2x squared minus 6x. 2x, right? And what's left in the parentheses? X minus 3. And then the x squared minus 1. Who's our expert at a difference of squares? X plus 1, x minus 1. Check. Okay, restrictions. Where all are we looking for restrictions? Remember, we are looking here. So we're going to say, in red, x does not equal what? What do you get from over here? X does not equal 3. X does not equal, okay, 3 and negative 4 come from that. How about up here? What comes from the x minus 3? What's the 0 of x minus 3? 3. Okay, but we already have a 3. What's the 0 of 2x? When it's a standalone x, what's the 0? 0, right? It's like x minus 0, right? So the 0 is 0. Okay, what about from x plus 1? Negative 1. And from the x minus 1, positive 1. So a lot of restrictions there. Okay, that's that. Okay, what are the common factors? Plus 4 looks right. And what else? Minus 3, right? Remember, it doesn't matter that this minus 3 is in the second fraction and this one is in the first fraction, right? You can still cancel. And anything else? Plus 1. Okay, so we canceled all the common factors, and now we just multiply straight across. Come on. So that will be 2x and x minus 1. Piece of cake, right? Check. Okay. So that was it, right? We simplified, we multiplied, and we divided. And next class, we got to add and subtract.